let's first look at which one of these, if you have your sheet here, which one is the most simple one? Look at all 12 of these and try to find the most simple one. You haven't seen the other page. Turn the other page. Well, they will be at first, but once you look at them, they'll make a lot more sense. Because that's what I'm saying is, I want you to be able to, if by the end of next week or week after that, be able to look at an equation and tell me basically what it looks like, what the graph looks like. That takes half of the strain away. So let's begin here. The constant function. For example, what if we had y equals 2? What we're going to talk about here, we're going to talk about the domain, the range, and the graph of this function. One way of graphing these things, if you don't know what the graph looks like, or don't know what the equation looks like, ask these 3 questions. One, can x be negative? 2, can x be 0? Can x be positive? You notice all these questions deal with x. When we say domain, we look at all possible values of x. So when we say domain, we're only talking about the x-axis, x variable. And that's why we ask, can x be negative? Can x be positive? Can x be 0? There's a note here. Note. A graph can only cross an axis if the equation has that letter. What does that mean? A graph can only cross an axis if the equation has that letter. Remember, our graph is made up of the x-axis and the y-axis. We talked about intercepts last time, didn't we? Yeah, so we can only have an x-intercept if the equation has an x in the equation. We can only cross the y-axis if there's a y in the equation. So, what do we notice about our equation? Are there any x's? No, so it can't cross the x-axis. These are all straight line. Oh, this is a straight line. So that means the graph looks like what? It only has a y, so it can only cross the y-axis. at 2. Or if you wanted to plot points, to graph an equation, always plot, if you need to, always plot points. Try some negatives, try 0, and try some positives. So if x is -2, what's y in our equation? Yeah, 2. When x is -1, 2. When x is 0, it's 2. So it's always 2. It's a constant function. So it's a horizontal line. So our example here is it's a horizontal line, bless you, crossing through 2. So what's the domain? Yes, but that's not how we say it. How far does it go to the left? How far does it go to the right? Not trick questions. Infinity or negative infinity. So the domain is from negative infinity to positive infinity. Here you go. Do you have this chart from last time? That's what we're working on. We just started it. Now, instead of another way of you can write this, since this is all the x values possible, we call that all real numbers. It stands for all real numbers. So what's the range? The range is the y values. What's the range of this equation? Look at the picture. Look at the y values only. What do you get? It's whatever the constant is. In our case, it's 2. So that's that equation. That's a constant equation. It's what's the slope of this equation? Think of slope face. 0. Remember his mouth? The zero's the end. So yeah, so if it's a horizontal line, it's the slope is 0, and it's the domain is from negative infinity to positive infinity, and the range is only 2. The next easy one is linear. Again, I want to know the domain, the range, So what's this number gonna look like? Is it gonna cross the x-axis? Well, yeah, because there's an x value in there. Is it gonna cross the y-axis? Yes, there's a y value. So what's the graph gonna look like? And don't say a line. If you don't see it, plug some points. Can x be negative? Well, let's see. If we plug in here, we have x and y. So if x is -2, what's y? -2. So at -2, it's -2. When x is -1, what's y? -1. When x is 0, is 0. When x is 1, y is 1. When x is 2, y is 2. This line is a diagonal line. Y equals x. And we've talked about these type of equations before. What's the slope of this equation? Positive what? Y1. Yes, that's true. It is positive. But remember, whatever's in front of the x is your slope in linear equations. What number is in front of x? A +1. And you're right. It's exactly right. If you go over 1, up 1, over 1, up 1, yes, that's the slope. So the slope of this one is 1. So the domain, how far on the x can it go? How far left on the x can it go? Yep, -infinity. How about to the right? Yes. But you're right, it is infinity, both directions. So it's, or we can write all real numbers. VR. How about the range? The range, how far down does it go? Where? -infinity, yes. And up? So it's the same thing. It's -infinity to +infinity. Or real, all real numbers. How do we know, just by looking at this, how do we know it's a linear equation? There's an x. Does x have a power? No. Does it have a square root? Does it have, is x on the bottom of anything? No. So that's why it's a linear equation. X is just x. There's nothing else around it. Because once you start putting special operations around it, then you start changing the shape of it. If you notice the constant function, there is no x. So there's no movement up and down. It's just the number 2. Absolute value. What does absolute value mean? There's a whole section where we're going to deal with this, but I don't see what you know so far. Remember, if we don't know the graph already, can x be negative? Can you put negatives inside there? If I put -2 in there, so the absolute value of -2 is what? 2. The absolute value takes whatever value, whatever numbers inside those lines, and just strips the sign away. It's just always going to be positive. So it's 2. So at -2, the answer is 2. When x is -1, what's the absolute value of -1 is? 1. When x is 0, what do we get? 0. When x is 1, no, it's just always going to be positive. So absolute value is a distance. Can you have a negative distance? In other words, how far is it from Dallas to Fort Worth? Let's say 23 miles. How far is it from Fort Worth to Dallas? 23 miles. It's not negative 23 miles. So absolute value is a distance of how far numbers are from each other. And since you never have a negative distance, so the absolute value of 1 is 1. The absolute value of 2 is 2. So the graph of an absolute value equation is a V. This one? That's equals absolute value of x. And we'll go through a whole explanation of absolute values, what they are a little later in section 6. So looking at this graph, what's the domain? Very good. Negative infinity to positive infinity, or all real numbers. Because when I ask you a domain, look at the going left. How far left can it go? It keeps on pointing that up to the left, so it goes to the left. And this one goes up to the right. So how about the range? What's my range going to be? So in other words, you ask, what's the lowest it can be? Look at the graph. What's the lowest it goes? 0. Yeah. So it starts at 0, and we can use 0, and it goes where? It goes up to infinity. So for the range, if you just took your pen or pencil and start, the lowest it can go is a 0, and the rest of the graph goes up, goes to infinity. The next one, quadratic equation. Y equals x squared. So can x be negative? Yeah. So if I had -2 and I square it, what do I get? Remember, what does square mean? So we had y equals x squared. If I had -2 and I square it, that means I have -2 times -2. Positive 4. And that's the thing we're talking about today. What's called a degree. When x is -2, y is 4. When x is -1, what's y? -1 squared? -1 times -1 is 1. True. That's why I said at 8 o'clock. How about 0? 0 squared. 0. Because remember, if you have an x value, you have to be able to cross or touch the x-axis. When x is 1, what's 1 squared? 1 times 1 is 1. When x is 2, 2 squared is 4. So this is a curve. The moment you have an exponent on x or any special operation, you've just changed its shape. It's no longer a straight line. This curve is called a parabola, or I call a parabola. It's a parabola. And we're going to see tons of these when we start solving these things. What's the domain? Or just look at your graph. Domain is the x-axis vertically. So how far left can I go? Yeah, it goes on forever and ever and ever. So -infinity. How about to the right? To positive infinity. So it's -infinity to positive infinity. Or you can write all real numbers. It doesn't matter which, either way you can write those things. How about the range? The range is the y-axis. What's the lowest you can go? Can you include 0? Yes, there's that point right there. So it's a bracket. And it goes where? To positive infinity. Very good. It's principle. From an earlier life, do you remember the difference between parentheses and brackets? What they mean? A bracket means I can go to that, I can use that number. Parenthesis means I cannot get to it. I cannot use it. I can get infinitely close to it, but I can't use it. Because can you ever get to infinity? No, that's why it's a parenthesis. Now a radical, or in this case, a square root. So what does a square root mean? Remember the 3 questions. Can x be negative? Can you have a negative inside a square root? Well, let's see why not. I'm trying to save you there. Hopefully everybody knows what the square root of 4 is. What is it? 2. Square root of 25. Square root of 100. You just divided it by 2. That's not. Now, why is this the case? What is 4 made up of? 2 times 2. Since we have two twos, that comes out. What's 25 made up of? 5 times 5. Since there's two fives, we can pull it out. What's 100 made up of? 10 times 10, which is 10. So the square root, well, before I go to, let's look at the cube root. Let's look at these possibilities. Cube root of 1. 1 is made up of 1 times 1 times 1. There's 3 of a kind, so it comes out. What's 8 made up of? 8 is made up of 2 times 4, isn't it? 4 is made up of 2 times 2. So we have 2 times 2 times 2. There's 3 of a kind, so it comes out. $27 is made up of 3 times 9. 9 is made up of 3 times 3. So it's made up of 3 times 3 times 3. Since there's 3 of a kind, the answer is 3. Now, hopefully that gives you a clue on how to solve these. This number here is called the root. Okay, get better. It's called the root. The root in a operation like this, it tells us how many of a kind do we need to take it outside. We had 3 ones. Since there's 3 of a kind, I can take it out. There's 3 of a kind, I can take it out. The logic works for these up here. These are called cube roots. Cube has 3 sides. That's why it's a cube root. This is called a square root. How many sides does a square root have? Of the square have? Sides? You have up and down. You have the length and the width. So there's an invisible 2 here. The root is a 2. It's an invisible 2, which tells us we need 2 of a kind. As soon as we have 2 of a kind, we take it outside the radical. That's what comes there. So if we had this, how many of a kind do we need? We need 5 of a kind. So you notice what I did? I took the number and broke it down to its smallest pieces. I can't go any further. 2 times 2 times 2. I can't go down any further. 3 times 3 times 3 is 27. So once you go down as far as you count how many elements you have. How about if I gave you cube root of 16? What would that equal? So your first step is to do what? Can you get it for you? I'm sorry, no, you don't. There. First thing you do is what? Take the number inside there and break it down to its smallest pieces. 16 is made up of what? What's that? 8 times 2. So 2 times 8. 2 is as far as you can go. Good. How about 8? What is 8 made up of? 2 times 4. And 4 is made up of 2 times 2. So 16 is made up of 2 times 2 times 2 times 2. So far, so good. So I broke it down as far as I can go. So 16 is made up of 2 times 2 times 2 times 2. How many of a kind do I need? I need 3 of a kind. Do I have 3 of a kind? Yes. Whatever's left stays inside there. So these 3 come out in front. Whatever's left stays inside. So there's my simplified version of it. These. Does it make sense? So that's how you simplify radicals. It all depends on what the root is. So now here's another thing. Can you take the square root of a -4? Why not? Because remember what we need. For example, 4 is made up of what? 2 times 2. They have to be exactly the same numbers. Can you break down -4 into 2 numbers? So -2 times -2 is what? +4, not negative. We can't go -2 times 2 because they're not the same numbers. So in square roots, you cannot have negatives inside there. Well, let's go even further than that. If the root is even, square root, 4th root, 6th root, 8th root, 10th root, you cannot have a negative inside there. If the root is odd, it can be positive or negative. Because -8 can be made up of -2 times -2 times -2. Because we have an odd number of negatives. So if it's even root, you cannot have a negative inside there. If it's an odd root, you can be positive, negative, or 0. Make a little bit more sense? So again, if the root is odd, 3rd root, 5th root, 7th root, 9th root, 11th root, then it can be positive or negative inside there. Which now goes what we need to talk about when we talk about our graph of our square root. So in our square root, we cannot have negative numbers. The answer cannot be negative. So what does the graph look like? Remember the three questions? Can x be negative? No. Can x be zero? Yeah, square root of 0 is 0. So we can have it at the origin. Square root of 1 is 1. Very good. Square root of 4. Yeah, we just talked about that. 2. So at 4, it's 2. At 9, square root of 9 is 3. So you notice how far it grows out before it goes up 1. So there's the graph. So what's the domain? Look at the picture. Can x be negative? No. So where is the smallest x can be? 0. So it can start at 0 and then go to where? Positive infinity. Or you can say that x is greater than or equal to 0. You can say either one of those. How about the range? Can your range be negative? No. Can it be 0? Yes. And it goes to positive infinity. Or y is greater than equal to 0. I can just explain to you. If the root is even, can you have negative numbers? No. So same thing here. If your power, the highest power is called the degree. The highest power in your equation is called a degree. Notice what's happening here. If your degree is even, 2 is even, your graph will look something like this. More importantly, if your degree is even, both ends of your graph will point the same direction, either up or down. That's called end behavior. The reason I say that is because in the cubic function, if I had x cubed, can x be negative? Yes, it can be negative. So if I had -2, -2 cubed is what? -2 times -2 times -2 is eight. Very good. Yes. -8. 2 times 2 is 4 times 2 is 8. And it's negative. So at -2, it goes all the way down to -8. At -1, -1 cubed is -1. At 0, it's 0. At 1, it's 1. At 2 is 8. 2 times 2 times 2 is 8. So the graph looks something like this. So if your degree is odd, then you can have positive, negative, and 0 answers. And you can use positive, negative, zeros. What's the domain? To, yeah, negative infinity, positive infinity. Or all real numbers. How about the range? All real numbers. So that's what that one's going to look like. If you notice, the square root, the x squared, because whenever I square something, it becomes positive. But if I cube it, I take this side and just fold it down. That's what that one is. Because in odd powers, I can go down. Even powers, I have to go up. How about the cube root? What's that one going to look like? Cube root of 0 is? So can x be negative? Yes, because it's an odd root. So I can have negative 8. If x is negative 8, cube root of negative 8 is negative 2. So what makes up negative 8? Negative 2, negative 2, negative 2. When I have negative 1, it's negative 1. At 0, it's 0. At 1, it's 1. And at positive 8, it's 2. There's that shape. And both the domain and range are all real numbers. I mean, I put this, you could put it either way. The computer will take both of those answers. It's the same one.
Okay, thank you.
So, okay, now I'm glad you asked that. Because notice in the last two ones that we did, these two and these two, they're inverses of each other. What does that mean? If you notice here, we had, well, let's see, 2, 4. If we go over here, we get 4, 2. If we would have gone 3, 9, here would have been 9, 3. These are inverses. -2, -2, -8, -8, -2. So the inverses are switched the numbers. We had 2, 8 is 8, 2. 1, 1. So these equations are inverses of each other. So far, so good? Because there's a whole section on inverses as well. And I'll also give you a heads up on it. The next easy one here. Let's do rational. Let's do rational. Okay, look at this equation here. Can x be negative? Yeah. If since 1 over -2 is the same thing as -1 over 2, so it's -1/2. Can x be 0? No, you cannot divide by 0. It's undefined. Can x be positive? Yes. So this one is an interesting function. One over x. Let's see if we can notice a pattern here. When x is 1, what's y? 1. Because 1 over 1 is 1. When x is 2, 1/2, which is 1 over 2. When x is 3, 1/3. When x is 10, what do we get? 1/10. When x is 100, what do we get? What do we notice about the bigger x becomes, what happens to y? It gets smaller. It gets closer to what number? It's closer to 0. Okay, so if we look at our graph here, when x is 1, when x is 2, when x is 4. So from here, it keeps on going down forever and ever and ever. What happens between 0 and 1? What happens to when x is between 0 and 1? Let's try 1/2. So if we had 1 over 1/2, take the top number and multiply by the flip of the bottom. We get 2 over 1, which is 2. What if we had when x is 1/10? What's y going to be? 10. X is 1 over 100? Yeah, you just flip it. So the closer we get to 0 on the x, the higher it goes. So that's what that graph looks like so far. When x is -1, the answer is -1. And -10 is -1/10. And it's just there. That's the graph of that function. Notice two things here. The graph never crosses where? Never crosses x equals 0 or y equals 0. Those are called asymptotes. We have a vertical asymptote at x equals 0. And we have a horizontal asymptote at y equals 0. So can you guess what asymptotes are? They're lines the graph cannot cross. They get close to it, but not supposed to cross. So asymptotes are lines where the graph approaches, but does not cross. So the vertical asymptote is what is the x values that make it undefined? The vertical asymptote is what are the x values that make the function undefined? In other words, what makes the bottom 0? Okay, so back to our chart, and let's do the picture. Let's do the picture. This gets very, 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 very close. Very, 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 very close. So the domain and the range. Here's where it gets complicated. Whenever you have asymptotes, you no longer have a continuous function. So the left side, we go from where? Negative infinity to 0. So it goes from negative infinity all the way, but we can't touch 0. Then we jump, take the union, and start at 0 and go on to positive infinity. Notice they're parentheses. They're not brackets. They're parentheses at 0. I cannot use 0 as an answer or an input. Same thing for the y values, for the range. I go from negative infinity all the way up, but very close to 0. And then just above 0 to infinity. So far, so good. What's the difference now between this equation and this equation? Kind of. Has what? Notice the exponent. What is this exponent here? Well, it's a 1. This one's odd, which means I can go positive and negatives. This one's even. which means all my answers have to be what? Positive. So it pretty much looks like the same graph. This one I call the Atari symbol. It looks like the Atari symbol. Because all we did was on the other equation, since we can't have any negatives, we flipped it over. We can only have positive answers. The domain is what? To where? Well, no, look at the graph. This one goes on forever there. It's just the answer, the y's cannot be negative. The x's can be positive or negative. This can't be zero. So it goes from negative infinity to zero, union with 0 to positive infinity. That's my domain. What about my range? Can my answer be negative? No. Can it be 0? You can never cross the x-axis. This number, the only way a fraction can equal 0 is if the top is 0. That's the only way a fraction can equal 0. Since it's a 1 on top, it can never get 0. So my range is just above 0 to infinity. Or y is strictly greater than 0. Because the only way a fraction can equal 0 is if the top is equal to 0. Since we don't have an x on top, we can't equal 0. Again, notice odd exponents, I can have positives and negatives. Evens, I cannot have negative answers. Exponential equation. Now, an exponential equation is when the power is the variable. This changes a whole bunch of things. Now, another thing, the base, the b, has to be strictly greater than 1. Cannot be negative. Because if it was negative, it would oscillate. It can't be 0, because 0 to any power is still 0. 1, it can't be 1. 1 to any power is always 1. So it has to be bigger than 1. The graph since b is greater than 1, it can never, so the answer can never be negative. Here's exponential. And we have a whole chapter set up on these next two, exponentials and logarithms. We have a chapter for each of those. Let's say we had 2 to the power x. In the next couple of classes, we're going to talk about exponents. More so, if I had 2 to the power negative 2, what do you think that equals? The negative exponent simply means change the location of that value. So it would be 1/4. The negative exponent simply means change the location of where that number is and drop the negative. So 2 to the power negative 10 is 1/2 to the 10th. So that's what it means. It means it gets very, 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 very small number. The bigger X becomes, the very smaller it becomes. Another thing. So X can be negative. The bigger the negative, the smaller the number becomes because it's 1/. What is 2 to the power 0? It's a 50-50 shot here. Anything to the power 0 is 1. And then anything else is positive, works. If we had 2, let's say to the power 3, we know what that is. So everything else works okay. So let's see what the graph looks like. The graph, the further out it goes in the negative, the smaller it becomes. At 0, it becomes 1, and then it goes up from there. It's an increasing function. And it always crosses through 1. Because whenever we have any number to the power 0, it's always 1. The domain is what? What's the domain of this function? Can your x's be negative? Yeah. Can your x's be 0? Yeah, it's okay. Can it be positive? So it's all real numbers. The range, on the other hand, can it be negative? No. Can it be 0? No. So the range is strictly greater than 0. I know I'm dumping a lot of stuff in your heads, but as we go through the semester, we'll see a bunch more of all these and it'll make a lot more sense. But the sooner you put this to memory, the better. Or not remember, to recognize them. All right? Logarithms. Remember, logarithms are inverses of exponentials. So that means this point here is 0, 1. I change it to 1, 0. And it looks like this. And there's a whole chapter we cover on logarithms. It's not that difficult. It's just that I'll just give you the graph right now. We can work it from there. The domain is what? What's the domain? No, because look at can x be negative? Nope. Can x be 0? No, it approaches it. So this one is that. Or x has to be bigger than 0. In other words, for logarithms, we cannot have a negative or a 0 in there. The range can be negative infinity to positive infinity. Or all real numbers. And the last one. is the greatest integer function. How many of you all seen that function before? You've probably seen it once before, but you never really used it. An example of this one would be human population. X is always time. So we have the first year, the second year, third year, fourth year, and we can go back in time. When you deal with population, can you have decimals of population? No. So the way this one looks like, if it's 0, it's 0. If it's 0.6, it's 0. If it's 0.8, it's 0. You can't have a 0.8 person. Up until you get to 1.0, then you have one person. And that person stays there until you get to 2. Then you have 2 people. That's what it looks like. It's a stair-stepper function. It was when you see those graphs of influenza when people get sick, it's always a curve. No, you can't have a 0.6 of a person that's sick. This is what it's going to look like. In other words, what this one says is just drop whatever's outside after the decimal. In other words, round to the left, round down to the left. The domain of this one is all real numbers. The range are all the integers. Okay, so that's what that graph looks like. It's a stair stepper. There are no decimals in the y's. You can have half a year or 3/4 of a year, but you cannot have 3/4 of a person. Any questions so far? Let's call it a day. Time of class. Today's Wednesday, isn't it?
Yeah.
I won't see you guys for a whole weekend.